that DM is parallel to EB. So which angles are congruent?
Angle B, angle D, and
This one and this one, for the same reason, right?
So you couldn't write that all in number 2?
Yes.
Oh, you are.
We're combining it because we're saying the same thing coming from the same statements. All right? Okay. Now that's all we can tell from parallel lines. So we go to our next part of our given statement, and it says this. It says that M is the midpoint of AB. And I know that because it was given. So using this as an if-then statement, if M is the midpoint of AB,
then AM is congruent to MB.
then AM is congruent to MB. Why?
Because
Definition of a midpoint. Now, ultimately, we're trying to prove that MD and BE are the same. If we can prove from this point that these two triangles are congruent to each other, and that those are corresponding parts, then yes, we can prove it. Are they congruent?
We don't.
Yeah,
Yeah,
that
angle side angle.
it was given that AM and BM are congruent, like those tick marks were given.
No.
We figured
I
it out.
put the tick marks after the given statement.
Oh, because that was part of the given statement.
After it said that M was the midpoint, if M is the midpoint, then yes, they are equal because they've been split in half.
So then it's angle side angle.
It's angle side angle. They are congruent to each other. Let's get our letters in order. If we have, trying not to spell a bad word, if we have MAD,
bad.
how would we put the letters of the other one?
BM.
BME.
Okay, MAD and BME. Oh, mad. Sorry. And we said that was through angle side angle. Okay, so now we want to know this.
I know.
Is MD congruent to BE? Well, look at the
Yes.
order of your letters. Are they in the
Yes.
same location?
Yes, because it's
Yes, they are.
I
So
have a-
you make your final
So
statement.
this is the first place we're introduced to CPCT.
Yep.
Miss Allen,
Oh,
are we
yeah.
going to be able to have our notebooks, our note cards on the exam? You said it was you.
I don't really use the theorems anymore.
Please. Because, well, if she does that with those, with the new stuff we've been going over, we have like a lot of stuff about those triangles.
Yeah, but you can't use it on that. You can only use them for the proofs.
No, no.
You
Are
can't use
you
it for
gonna
the whole
have?
test.
Are you gonna have proofs with the triangles?
I don't know yet.
How many
There
grades
is
are you
a
gonna
lot.
have?
Proofs?
Okay.
I'll decide later. Right now, you need to study like if you can't. That way, if you can, it's present. Yes.
Okay. CPCT, congruent parts.
Corresponding parts.
Okay. Can you go over that step 5 and 6 real quick again? Just
Okay.
like,
We are trying to get enough information to prove that the two triangles are congruent to each other. Because if we can prove that, then we know that all of the corresponding parts are congruent to each other. And we're trying to figure out if these two sides are the same. Well, once I prove that they are congruent and I list out the letters in the right order, I see that MD and BE do correspond. They are in the same locations. They are the corresponding sides.
so that's how you get from 4 to 5. How do you get from 4 to 5? You just kind of have to work with it.
No, you look at your picture. From 4 to 5, we have all these markings now. And in one triangle, I have an angle side angle marked. And in another triangle, I have an angle side angle marked. So that's enough information to go ahead and say, yes, they are congruent. Okay?
Thank you.
All right. Moving on. The other thing you need to know in Chapter 4 is the relationships of isosceles triangles. First thing is that in isosceles triangles we have two equal sides. We also have two equal angles. And we call them the what? The base angles. The third angle is called the vertex angle. All right? That's supposed to be an arrow. It's not working it. Whatever. Okay. Very simple. Okay? Understanding. If you know that two sides are equal, you automatically know that the base angles are equal. If you know that there are two equal angles, you automatically know it's isosceles.
Well, isn't it technically like the side across from the angle? But we don't really need to know that for isosceles, right?
Right, because there's only,
3.
it's kind of obvious. All right,
That's for parallelograms. What is that for?
trapezoids.
Trapezoids.
Okay, now, if I gave you information such as this, if I said this is a 65-degree angle, this has a measure of 8, this has a measure of 8, find the value of x here. Okay, Lauren?
Okay, well, since it's isosceles, the other triangle's gonna be 65. I mean, the other angle's gonna be 65.
Okay, very
so
good.
Then you add those up, and then you subtract it from 180, and you'll get x.
Which is what?
That's a lot. Hold on. Okay, it's 130. It's 50.
X is 50. Very good.
You're so smart.
And that's just using the properties of isosceles triangles. Understanding those concepts, okay?
I know, right? Brilliant.
If I told you that this was 40 degrees, and these two sides were equal, and I asked you to find x now,
What 40, and then you have to split it up by 100 to 50-50. I mean, 120 to 60-60.
very good. You know that since it's isosceles, these are exactly the same. So you take your remaining degree measure, which is 140 actually,
Oh man, I missed it again.
and you split it in half. So they would be 70. The value of x would be 70.
Dude, that's why I need calculators.
All right, on page 137, there will be questions like those, numbers 1 through 8. Here's an example. It's dealing with properties of isosceles trapezoids and then throwing some algebra into it.
Those equal each other.
They equal each other. Since we know that the base angles are equal, we know that these two sides equal. So to be able to solve this, I set them equal and I form an equation. If you subtract 2x from both sides, you have 3x over here. If you add 8 to both sides, you got 15 over here.
X equals 5.
So x is 5. Now the thing that might get you is I might not ask what is x. I might say what is the length of the side.
So then it would be 25 minus 8, whatever that is, 13. No, not 13. 20. Never mind.
How do you have
17.
where did
17.
the 2 come from? There's like a line in between.
That was just a marking to show that those two sides were equal. So if they're equal, I set up the equation, these two things equal.
Oh, you just worked it out.
And then I worked it out. It's just, it's still inside my triangle.
And how do you find the line?
Well, if x is 5, you plug 5 in here or 5 in here. Either way, you're going to get 17. Because 25 minus 8 is 17, 10 plus 7 is 17.
And I could have chosen that.
Using properties of isosceles triangles. Okay. That's it for chapter 4. We're going to pick up with chapter 5 tomorrow.
Good review.
Success!
Bye. I hope you feel better.